Hi everyone, first of all, I would like to explain about mushroom cultivation for the species of Pleurotus ostreatus. Its common name is oyster mushroom. It's usually grown on substrate like straw, sawdust and agricultural waste. Its optimum temperature to grow is between 24 to 28 degrees and humidity needed is between 80 to 90%. We can harvest this mushroom 3 to 4 times in a week. Example characteristic of oyster mushroom is it has fan-shaped caps and white gills. This mushroom is important because it contains high protein, exhibit antioxidant, and also fast-growing and easy to cultivate. Oyster mushroom also can be used as mycoremediation, which is the process to remove pollutant by using mushroom. For the next part, I will explain about mushroom cultivation of Pleurotus ostreatus. Mushroom cultivation is an agricultural practice that uses agricultural waste to produce high nutrient food. Commercial mushroom cultivation in Malaysia began in 1916 and has since gained increasing attention due to its health benefit. For example, can reduce cholesterol. This industry continues to develop and advance to this day because of the strong government support and introduce of advanced technology. Oyster mushroom is the most popular mushroom cultivated in Asia due to their high nutritional content, affordability, and adaptability to inexpensive substrate. To sum up, favorable cultivation conditions play an essential role in sustained production and maintain high quality yield of mushrooms. Objective of this project is to observe, monitor, and record data on the growth of Pleurotus ostreatus. We collect data like time of pinhead appearance, counting fruiting bodies, measuring mushroom weight, monitoring mycelial growth, and any contamination occurrence. Another objective is we analyze parameters such as weight and head of Pleurotus ostreatus a long time. We collect valuable data which are height and weight of the mushroom blocks from start till end of the project.
For this slide, I will explain the method used in our mushroom cultivation process. First is substrate preparation. The material used were sawdust, rice bran, dolomite, and calcium carbonate. All the materials were mixed properly and then packed into polypropylene plastic bag with about 1 kilogram of substrate per bag. After that, the substrate bag were sterilized using the cold sterilization method to reduce contamination. Next is spawn preparation. 1 spoon of grain spawn containing actively growing mushroom mycelium was added into each substrate bag. After adding the spawn, the bag were sealed using a stapler to prevent contamination. Then, incubation process. The inoculated bag were kept in a clean room with suitable temperature and minimal light. The mycelium growth was observed daily until the substrate was fully colonized. During this stage, airflow and humidity were carefully controlled to ensure good mycelium growth. After incubation, the mushrooms were ready for harvesting. The mushrooms were harvested when the caps were fully developed. Harvesting was done by cutting the mushroom clusters directly from the substrate. Finally, we carry out data collection. The data collected included the time taken for complete mycelium colonization, the number of fruiting bodies produced per bag, the fresh weight of harvested mushroom, and the total yield per bag. These methods allow us to monitor mushroom growth effectively and evaluate the overall productivity of the cultivation process. For this slide, I will explain. We will show a video demonstrating the mushroom cultivation process from start to finish. The video highlights each key stage, starting from substrate preparation, spawn inoculation, incubation, and finally the harvesting of mushroom. Next is result of mushroom cultivation. The summary result of our mushroom cultivation is both block, commercial and self-prepared is successful. In a few weeks after the initial mycelium colonization, our mushrooms start growing pinheads and keep growing till harvest. Elevation of the mushrooms start at convex and becoming flat over time. Some give round edge while some irregular. Next, weight of the block observed decrease from the initial weight before the mushrooms start growing and harvested. Lastly, the color observed range from white cream to grayish white.
Is the discussion about the growth and yield performance of oyster mushroom into different substrates. So for self-prepared substrate, it shows slower and less uniform mycelial colonization, late and less complete substrate coverage, which is result in lower yield across all harvest cycle. Mushroom growth in this substrate were fewer fruiting body, shorter in head and had lower fresh weight. In contrast, the commercial substrate show faster and more uniform mycelial colonization, faster and more complete substrate coverage. This substrate also produce a higher yield across all harvests. It can be shown in the greater number of fruiting body, taller mushroom and higher fresh weight. So for both substrate, the peak production during the second flush, which is the week 7 and week 8. This slide is about the effect of contamination on mushroom growth and yield. No contamination was observed in commercial substrate throughout the cultivation period. This shows that effective sterilization and stable growth conditions that allow mycelium to grow without competition from other microorganisms. On the other hand, minor contamination was detected in self-prepared substrate starting from the first harvest. Although mushroom growth was not completely inhibited, the contamination reduced the nutrient availability and caused mycelial stress. As a result, the self-prepared substrate show slower pinhead development, smaller mushroom size and lower overall yield. There are few limitations to this study that should be noted. First, the self-prepared substrate may require improved formulation and sterilization method to enhance its performance and reduce its contamination risk. Although environmental conditions were controlled, some variation in temperature and humidity could have occurred.
In conclusion, Pleurotus ostreatus was successfully cultivated in this project, where the mushrooms completed all growth stages from mycelial colonization until harvest. When comparing substrates, the commercial substrate performed better than the self-prepared substrate. It showed faster and more uniform mycelial growth, earlier pinhead formation, and produced taller mushrooms with higher fresh weight and yield.
The self-prepared substrate experienced minor contamination, which affected nutrient availability and resulted in slower growth and lower yield. Overall, this study shows that proper substrate preparation, effective sterilization, and good environmental control are very important for successful mushroom cultivation. Oyster mushroom cultivation is a sustainable and low-cost agricultural practice with strong nutritional and economic potential, especially in Malaysia.